So today we're going to talk about function notation, okay? And the simple idea here is we're going to replace y with this thing called f of x. Functions are given a single letter name, okay? These names can be upper or lower case. Most of the time you're going to see lower case, except when we deal with story problems. A lot of story problems will have that uppercase. Y equals f of x here is really read as, well, y equals f of x. And we're just going to interchange the two. This is not f times x. So that's the important thing to realize. That's not f times x. That's f of x. Okay? The idea here is y is some function of x called f. That's what we're really talking about. Y is some function of x called f. So let's look at some examples where we see this function notation. Okay, so in example 1, the function f is defined by f of x equals x squared minus 2x minus 3. Here you can see the function is named with lowercase number, or letter, excuse me. And the first part here, part A, we're going to really ask, what does f of 5 equals 12 mean? The basic idea is if you plug 5 in for x, the output, your y value, is 12. And that's what we say here. When the input x is 5, the output y is 12. F includes 5, 12 as an ordered pair, meaning 5, 12 is a solution to this function. It will be on the graph when we plot. If we plotted this graph, which we'll do in a later unit, that point will go through the graph. It'll be somewhere on that graph. So really, this is just x and y. The idea is f of x is just being, it's replacing your y coordinate here. So part B, we're going to evaluate f of negative 2 and explain what that means. So unlike part A, we're not given what f of negative 2 is. We actually have to find that. So what does that mean? So f of negative 2 is read f of negative 2. And means the value of f when x equals negative 2. So what is the y value? What is the f of x value when x equals negative 2? Well, in order to do that, you have to plug in what you know for x. So instead of writing f of x now, I write negative 2. And I replace every x with negative 2. So I've gone through and done that in my function, and now it's a matter of simplification. So we get 4 plus 4 minus 3, which is 5. So f of negative 2 is 5. So the point negative 2, 5 will also be on that graph. It is a solution to that function. So what does f of x equal y mean? Well, in this problem, it is the shorthand way to write this equation. So if I say y equals f of x, okay, we don't have to write this big long equation. We know that f of x is actually equal to this. We said that in the beginning, in the example. So those are just a few things we can learn about what does f of negative 2, f of 5 mean. What does it mean when we plug a value into the function? You know, so you plug in x into the function, and the output is your y value. Okay. In example 2, we have a little bit different. It's not much different of a function. F of x is f is defined by f of x equals x squared minus 2x plus 3, and now we're asked to find f of x plus 5 and simplify it. So now this is a little bit different. In example 1, I gave you a specific number for x. Okay, this number, this x in parentheses, changes. That's now x plus 5. This is called our argument. When we have this in parentheses in our function, that's our argument. So what we're saying is, let's plug x plus 5 in for every x in our function and see what we get. So you notice here it's not f of x now. I'm replacing x with x plus 5. So in the equation, wherever I see an x, x plus 5 goes. So notice here, x is replaced by x plus 5, x is replaced by x plus 5. And now I have to simplify. Big hint here, when you're multiplying, when you have x plus 5 squared, you can think of this pattern. A plus b squared is equal to a squared plus 2ab plus b squared. That's how I got this in red here. So I plugged in x plus 5 in for x. Now I have to simplify, and I've done that all the way across. And I have to combine like terms. Notice I have 10x and minus 2x, that's 8x. 25 minus 10 is 15, plus 3 is 18. So now I've plugged in x plus 5 into my function, and I've simplified as far as I can go. In example 3, I have f of x equals x squared over x plus 4, and I want to find f of x minus 3. So again, I write my equation. Instead of x for my argument, I have x minus 3. So in my function, wherever I see an x, that's replaced by x minus 3, and I've done that here. So now I have to expand the numerator, which is x squared minus 6x plus 9. And I just have to combine the like terms in the denominator. Negative 3 plus 4 is 1. And so now I look, I can't simplify anything. These x's don't cancel. Okay, so be very careful how you simplify. That's all I can do. And let's go on to our next example. In example 4, if our function is 2x squared minus x, find f of x plus h, and simplify it. Now this is a really important idea, this f of x plus h. You're going to see that in pre-calculus when you start to work a little bit with the difference quotient, and you're going to see it again in calculus. So this is a good thing to have. Notice there's not a number here for h, they're both variables. Okay, so I have 2x squared minus x. Now instead of x, I have x plus h. So again, wherever I see x, x plus h takes its spot. There's my expansion here in parentheses. Okay, notice I left the 2 outside because I have to expand x plus h squared first. Got to follow my order of operations. The opposite of x plus h is minus x minus h. So I get 2x squared plus 4xh plus 2h squared. That comes from multiplying 2 to all these terms in red. And I drop down my x, subtraction of x, and subtraction of h. I do not have any like terms I can add, so I'm done with the problem. That's as far as I can go. So we've finished our idea of what function notation is, where we replace our y with f of x. F of x is still your y value. It's still your output. If you plug in an x, what's your y value? What's your f of x value? Okay. So if you have any questions or comments, please type them below, or you can email me at nicholas.bennett@dc.gov. Thanks.